we're going to be going through the coordinate plane. Historically, you guys have only done one quadrant, what we call quadrant 1. And we're going to practice with that a little bit at the start. So here's your major focus. We're going to identify all 4 quadrants and the characteristics of the points that are in them. You're going to locate and plot ordered pairs of positive and negative rational numbers on the coordinate plane. You're going to look at the relationship between the signs of the coordinates of ordered pairs and the reflections across one or both axes, meaning either the x or the y axis, or you can reflect across both. We're going to talk a little bit about absolute value for determining distances, and you're going to solve problems by graphing points in all 4 quadrants. Yes?
What is a quadrant?
Quadrant, good question. This right here is a quadrant.
It's like one square.
It's like one of the square sections within the coordinate plane. So in order to help us get back into review and make sure everybody understands how, we have 5 points we want you to plot and label. And then after we get this, and we're comfortable with everybody plotting your points, then we'll be able to move into the rest of today's lessons, where we're going to move into some of the other quadrants. So we'll give you guys about 3 minutes to plot these 5 points. Okay, I'd love to hear Mr. Deacon going around giving great advice to everybody. He's like, guys, you always start at origin. Start at the 0, 0. My first number is telling me my left, right. So 3 means I'm going to start at 0. I go over to 3. My second number means I go up to 5. Once I've made my second move, then I put my dot. For part B, I do the same thing. I go back to 0, 0. 0 means I'm not moving left or right. 4 means I'm going straight up. So my B should have been here. C, I go back to 0. I go over 6, up 1. There is C. D, I start at 0. I go over 8. 0 means I'm not moving. So I'm just staying right there. And our last one, Z, E, 0. 0 means I don't move anywhere. I stay right there at the start. That's what your graph should have looked like. Everybody good on that?
No.
Yes. You could have. I just like going in order. It makes it easier for me to keep track of it. Okay, let's go to 570. So this is what you guys have used. This is what we call a coordinate plane. So far, you guys have just been using one quadrant of the coordinate plane. So we're going to do the coordinate plane, but now we're going to talk about points where the x and y coordinates were both 0 or positive. That's all you have done so far if you've been in the DODEA system, because that's what our standards say. We're going to change that up a little bit today. We've now been learning about number lines. That's about the last month talking about number lines, negative numbers, getting those introduced. So now, what do you know about the number line that makes up the x-axis? In other words, this one. Does this actually look like a whole number line?
No.
No. So we want you guys to extend that number line and label it. Also, we have a number line that makes up the y-axis, right? In other words, this one. But it only has positive numbers. So if it's a number line, does that make sense?
Yeah.
So we've done vertical and horizontal number lines. Could you guys now do something to the y-axis to extend that and label it? I hope so. So I want you guys to go ahead and do that. This should take you all about 2 minutes. You're going to extend both of those 2 number lines and label them.
What do you mean by extend?
Extend.
Make it bigger?
Make it long. Extend means make it longer. So do I need to make it any longer to the right?
Yeah. Oh, I know.
No, it has an arrow there.
Oh, like
Could I make it longer to the left? Yes. So,
oh.
think what I want you to know about what we've taught you about number lines. I want you to extend both of those number lines to include your negative numbers. There's your big hint. So, guys, what you should have done, you should have taken your x-axis, extended it to the left. You should have taken your y-axis, extended it down. And after you did that, you're now going to continue your intervals. So you should have had about the same intervals that you started with. And you start labeling it. Now I'm going in negative direction. So -1, -2, -3, -4, -5, -6. We do the same thing as we are going down. About the same interval as they had, but now you're extending it into the negatives. Yes?
What about? It says that. What about something?
I did mine a little bit bigger, so I didn't get the 7. I'm using the same line I used last time, so that's why they were up there. I used those last times. Does this make sense for everybody? Do you understand where these come from? Yeah. Guys, your coordinate plane is literally just 2 number lines that intersect. Now, where they intersect is actually really important. The point where your x-axis and y intersect is known as the origin. I want you guys to get out your highlighters. We're going to highlight this one. I hope you know the origin. So, the point where the x and y axis intersect. Guys, we're recording. Okay, so you guys should have origin. The other big term that we're going to get today, the regions on the coordinate plane are broken into what we call quadrants. In our quadrants, we number them with Roman numerals from 1 to 4, starting in the upper right. Okay? So here's where it always gets confusing for me, I'll be honest. Because to me, the first one makes sense. If I were to be the guy that made up coordinate planes, and I was looking at it, and I said, okay, if I've got 4 quadrants, where would I put the first one?
Right there.
Right there. That makes sense. What doesn't make sense for me, because I would then say, well, if that's 1, 2 should be here, right? No. 2 is here.
That makes sense.
Going counterclockwise is kind of counterintuitive for most people. But realize I'm going counterclockwise, so that means quadrant 3 is down here, meaning the last one that we have is quadrant 4. So those are your Roman numerals. That is how we use we talk about quadrants in our coordinate plane. So if we ask you what quadrant a point is in, those are your 4 quadrants. You have 2 other major pieces. That is your x-axis and your y-axis. So those 6 pieces kind of make up your coordinate plane. The one last piece that we don't have is your origin. Your origin is that point right here in the middle. Origin. And when we talk about points, we always use what we call ordered pairs. So ordered pairs are sets of numbers that show the location in a coordinate plane. We always use parentheses around the ordered pairs. I always list my x coordinate first, I put a comma, and I list my y coordinate second. We will always do that. So when I talk about origin, if I were to ask you where origin is, you would have to write down 0, 0. So that point where those 2 number lines intersect is what we call origin. Everybody good so far? So this page is a lot of terminology, but if you're understanding the terminology, that's going to help you as we continue to move forward. Everybody good? Okay. Go to our next page. We're not going to do the human because quite frankly, it would take too long, especially with as many people as we have in here. So instead, I've written a whole bunch of locations. I've given you the ordered pairs for them. What I want you guys to do is plot all 14 of these points on the coordinate plane. Okay?
What?
14. So write down the coordinates, the ordered pairs for all 14 points. Then you're going to plot all 14 of them onto your coordinate plane. So we have 14 points. I know this is going to take you guys a little bit. So I'm going to give you guys about 10 minutes to write all this down and go ahead and plot the point. Guys, this note here was actually really critical about your first and the second. This is how you are going to plot points. It's why every mathematician in the world who has the point 2, -6 is going to put it at the same point. And it's not where I saw the majority of you putting it. Okay? My first number is telling me left or right. If it's positive, I'm going right. If it's negative, I'm going down. So positive 2 means I always start at origin. And then I'm going to go over 2. -6 tells me it's going down. So 2 -6 is actually here. The vast majority of people I saw put it here. That's not right. Okay?
Oh, I got it right.
Quiet. Quiet, guys. For those of you that got it right, I'm glad you did. But we have a lot of people that weren't, so we need to go through these. So our next one, -4. So again, I always go back to origin. My first number is a -4, means I'm going left. -1 means I'm going down. So there is B. C is at 0, 0. That's our origin point. So that's right there in the middle. D, again, I go back to origin. My first number 4 means I'm going 4 to the right. 0 means I'm not going up or down. So there's D. E, 0 means I'm not going left or right. 7 means I'm going straight up all the way to the top. There's E. F, -1 means I'm going 1 to the left, then up 4. There is F. G, 1 means I'm going right. -4 means I'm going down. There's G. H, -2 going left to, -6 going all the way down to here. I, 0 means I'm not moving. -6 means I'm coming straight down. There's I. J, -3 means I'm going 3 to the left. 0 means I'm not moving. So stay right on that line. There's J. K, -4. So I'm going left. +2. That's going up. Here's K. L, 3. So I'm going 3 to the right. -3 means I'm coming down. There's L. -3 means I'm going 3 to the left. 3 means I'm coming up. So that is M. And our last one, -6 means I'm going 6 to the left. 0 means I'm not moving off the line. So there is N. That is what your graph should have looked like. Are you guys starting to see how the process goes? I heard way too many no's on that one. So guys, really quickly, those of you who said no, which parts it's confusing to you? I'll say someone who said no, to be honest. Mason, are you okay? Guys, there's 3 parts to it. Part number 1, start at origin. Start in the middle. Part number 2, look at the first number. If it's positive, I go right. If it's negative, I go left. From that point, I then look at the second number. If it's positive, I go up. If it's negative, I go down. That's all there is to it. So if you need some more practice, you'll get some more in your homework tonight. We'll get a little more practice as we go about it today, too. Now, when I'm looking at this, if I'm looking at the ones that are in the same quadrant, we just talked about quadrants last time, right? So we've got quadrants 1, 2, 3, and 4. If I look at all of these points that are in quadrant 1, K, M, and F, what do you notice about these quadrants? There's those points. There's F, there's K, there's M. Do you see any similarities between them? Look at those numbers. Look at the ordered pairs. Do you see any similarities with those ordered pairs? Every time, right? Okay. So in quadrant 2, if I have a point here, my first x coordinate is going to be a negative. My second y coordinate is going to be a positive. Okay. What about the ones that are down here in quadrant 3? Something about those.
Yeah.
What, Rain? He just said yeah.
No. It's like, -6.
What about the second one?
The second one is positive.
E and H?
Yeah. Oh, they're both negative.
Oh, they're both negative. Guys, that's always going to be the case.
Wait, number 3.
If they are in 3, they are both negative. Okay? When I made up the numbers, I actually didn't put any in 1, but we've been doing that forever, and we'll get to that in a second. What about our ones in quadrant 4? We have three of them, G, L, and A. So A, G, and L, what do you notice about those? Negative, positive X, and then negative Y. So given that pattern, what do you think we'll find about all the points in quadrant 1? Good. So do I actually have to graph the point to know what quadrant it's in? No. Now there's a few points we haven't talked about yet. What about like N, J, and D? What quadrant are those in? How can they be in 2 quadrants? What's the similarity between those? If I look at J, D, N, and J, what's similar about all those? In all of them, right? So what do we know if that second one is 0? Where is it actually located? What axis? X. So if my Y is a 0, it's going to be on the x-axis, which gets to our next question. What if my x's are 0s? Where are those located? The y-axis. Okay? So for x, it's going to be either a positive or a negative. I'm going to move, but then my second one is going to be a 0. For my y-axis, my first number is going to be a 0, excuse me, and then my second is going to be either a positive or a negative. Go either way. Make sense? We'll get some more practice on this, but we just wanted to get those basics down to get you guys started. Okay, let's go to our next page. Now we're going to kind of go the opposite way. I'm going to give you guys 5 points. Now I want you to take the 5 points and figure out what the location is. In other words, give me the ordered pair for those 5 points. If you need to, you may go to one of the boards. You can't use the front board because people were erasing the points. But if you can't really see where it is, feel free to go any of the other 3 boards to figure it out. You guys have about 4 minutes to write down these 5 points. On all of these, you have to start by starting at origin. Okay? I will say I'm really disappointed. I saw some of you did not put parentheses around your ordered pairs. Okay? As I start at origin, to get to A, I'm going left. That means it's going to be a negative. I go over until I get to it. That's at -6. So then I can write it down. I put a comma. Then I say, oh, wait, now I'm going up. That's going to be a positive, and I go 4 places. So the ordered pair is -6, 4. Then I come back to origin. Now I'm looking at point B. I'm going 3 to the right. So I start, and I write down my 3. Then I have to go down 4. So that's going to be a -4. Then I go back to origin. In my first point, to get to C, I'm going right 6 places. So my first one is a 6. Then I don't move. That means my second one is a 0. On my next one, now I'm going to D. So again, I go back to origin. Now I'm going 3 to the left. So that means it's a -3. Then I'm going up 2 places. So that makes it a +2. Then our last one, I come back to origin. I'm going left again, 6 places. Makes that a -6. Then I'm going down 4. So it's a -4. That is what your answer key should have looked like. How many of you were able to get all those right? Thumbs up. Okay, that's actually not. Guys, listen up. We kind of did this on the last one. I got ahead of myself. But if I compare the ordered pairs I plotted and identified in this activity, what is similar about the points you graphed in each region or on each axis of the graph? So for all the ones we did in quadrant 1, what did we notice about them? About the coordinates? Not in quadrant 1. What did I know about both of them? Both positive. If they're in quadrant 1, they're going to both be positive. What about quadrant 2? What did we notice about those points? Negative, both negative?
Negative. Positive. Negative.
Negative, positive.
Negative.
Negative x, positive y.
So that's the x-axis.
That's positive. Okay. What did we notice about quadrant 3? Negative,
Positive.
negative.
Negative.
They're both negative. What about for quadrant 4? All right, stop the chatter. What about for quadrant 4? Positive, negative. What about if it's on the x-axis? If it's on the x-axis, it's on that line. It could be positive or negative, right? But then what about the y number? It's going to be a 0. So I'm not going to go up or down. That's what puts it on the x-axis.
What is that?
Positive or negative. So I go left or right. And for the y-axis, that means I'm not going to move. It's a 0. And then I can either go up or down. So it'll be either positive or negative.
What? That means you can either one direction.
It means I can go either direction. I can go up or down.
Oh.
Everybody good?
Yeah.
Okay. So at this point, you should now be able to identify all 4 quadrants. You should also be able to plot the points. You should be able to tell me, even without plotting them, which quadrant they're located in based on the signs. Now we're going to talk about our next step. This is what we call reflection. So we don't have patty paper. Instead, we're going to just do this manually.
Patty paper.
Patty paper is like a see-through paper, so I can plot it and then fold it.
Oh.
So we're not actually going to do the folding of the patty paper. Instead, what I'm going to do, I'm going to plot and label the point. So I'm going to go to 4, 1. So I go over 4, up 1. I'm going to put my point A. Okay? I'm labeling my point. Now, at this point, if I talk about this, the way I say that is A prime. So it's saying it's A, but it's in a different position. The way we're going to do this is we're going to reflect on the x-axis. So all I'm going to do is I'm going to take my point A, I'm going to say how far above that x-axis is it? 1. So now I'm going to go the other direction. So if it was down, I go up, up I go down. And I'm going to put it on the same line, but in the other direction, the same distance away. So this is going to be my A prime. So if I look at that, that's now at 4, negative 1.
Why do you call it prime?
Because it's the same point, it's just being reflected. The prime normally shows a reflection or a movement of this point.
Why isn't the 4 negative?
Is it now negative, Asher? It's just 4. That's why I said it's 4. But why is it not negative? Because it's still 4. I didn't move on the y-axis. I only moved over the x-axis. Guys, so this is what reflection means. Reflection means it's the same distance the other way from that axis. Right now we're reflecting over the x-axis. So you have 3 more points to plot, but I also want you to reflect those points over the x-axis. In other words, it should be the same distance either above or below as the original point. We'll give you guys about 4 minutes on this one. Okay, most of you seem to be doing a lot better at this point. So I'm going to go through this one relatively quickly. So again, guys, always start at origin. Put your pencil at origin. Make the rest of it much easier. Negative 3 means I'm coming left. 4 means I'm going up. So B should have been here. Now I need to stay at that same spot, but I'm now going to the other side for my B prime, meaning the negative 3 stayed, but now I went down to negative 4. Next one, I go over to 5, up to 2. There's where C is. So C prime, oops, I'm sorry. That's C prime. Negative 2 for C. So 5, and then I went above for the second one. So C prime, C is below, C prime is above. Our last one, 0, means I don't move. Negative 7 goes all the way down here at the bottom. So D prime, I stay at 0, but now we go 7 up. So D prime is going to be all the way up here at 0, 7. when I look at this, what do I notice about the coordinates between my original points and my reflections? Asher? Okay, same distance from 0 on the x-axis. What about the y-axis?
Yeah. Same for mine.
Oh, you guys were given a different D?
Yeah, but that
That's
makes
interesting. One last class.
no. I got
So if yours is different than mine, that's fine. Just make sure.
yeah, it's right. But you guys are on the different.
Guys, we've established some people have a different number. That's okay. The concept is the same. I still haven't really heard it yet. If I look at the ordered pairs, did any of my x's change?
No, oh yeah.
Which one?
C.
No, 5 and 5. That's still the same.
Fine.
No, that's the y.
That is the
My question was, did any of my x's change? Did any of my y's change?
Yeah.
How did they change?
It's opposite. Reflection.
Thank you. I had one person, who I won't name since it's on YouTube, said it was negative. That's not true. I had another that said it was opposite. Yes, that is correct. So with my y, when I reflect over the x-axis, my y changes to the opposite. I went from -1 to -1, 4 to -4, -2 to 2. So did it become negative? No, it went to the opposite. So what can we say about reflecting over the x-axis? The y coordinate. That's where we got to be really specific in our verbiage, guys. I know it sounds kind of really petty, but this is actually really important. We've got two different things we're talking about here. We're talking about the x-axis. That's this line right here that we're reflecting over. But we're also talking about the coordinates. This is the x-coordinate. This is the y-coordinate. So be very careful in how and what you are saying, because what you're saying makes a difference. So when we reflect over the x-axis, what happened to the x-coordinate? Stayed the same. So my x-coordinate stayed the same. But the y-coordinate changed to its opposite. So leave that up there for a second for you guys to make sure you get it written down, because it's really important when we talk about reflection. Guys, sorry, we'll come back in a minute, but we need to get this exercise done. And now we're going to do the exact same thing,
Now it's 3.
but instead of going over the x-axis, now we're going to reflect over the y-axis. Listen. So again, I will give you an example. So my first point is up 4, 1. So we go over 1, 2, 3, 4, up 1. Here's where A is. But I'm now reflecting over the y-axis. So now I want to reflect over the y. So that means this is 4 to the right of it. So guess where the reflection is going to be? 4 to the left of it. So my A prime is going to be over here. So that's at -4. What? You guys now have 3 more to do, but hopefully you're seeing the pattern. This one shouldn't take you but about 2 minutes. Okay, I wanted to get the absolute value, so we need to go through this one really quickly. So my B is at -3, 4, meaning my reflection is going to be 3 to the other side. So my B prime is here, means that one is at 3, 4. 5, -2, put C down here. I'm going over the x-axis, means I'm going to go 5 the other direction. but in the same spot. So that gives me a -5, -2. Then I have -3, 0. So it's right on the line. Meaning I now need to go 3 to the positive side, but stay at 0. So 3, 0. So what do you notice about these points? Do you notice any patterns in your coordinate ordered pairs, the coordinates? There are different quadrants, but how do the ordered pairs change when I reflect over the y-axis? What switches? That's because I'm reflecting over the other axis, but what do you notice about the ordered pairs themselves? David? No? Rain? What symbols?
All the negative and positive.
And how do they change?
So the positive numbers.
So they're all positive on the second one?
No, like opposite.
Oh, opposite. Oh, that sounds really familiar. But what changed? Was it the x or the y?
X-axis.
So when we reflect over the y-axis, the x coordinate, not the x, changes to its opposite. What happens to the y?
Stays the same.
But the y stays the same. We have the official countdown now. Thank you. Not really. It's confusing. When I reflected over the x-axis, what changed? The y-coordinate. When I reflect over the y-axis, what changed? The x-coordinate. So that's your big key takeaway on this. So, guys, please remember that as you're doing reflection. So let's go really quickly to 577. Okay, page 577. If I'm looking at 2 points, A and B, and I wanted to figure out how far apart they are, if I use the coordinate plane to determine the distance from point A to point B, point A is at 4, point B is at -9. If I wanted to say how far apart they are, how far apart would they be? How did you get that? Why did you add them? One's a -9, one's a 4. Okay, so like everything you said except the difference. Guys, what is it I'm actually doing here? Finding a distance, right?
Oh yeah.
So between B and origin, that's a -9. But what is that actual distance? 9. It's 9 points away from origin, yes?
Yeah.
It's just in a negative direction. What about the A? How far away from origin is that? 4. Even though it's in a positive direction. So the big key on this, what you just did, you went from a -9 to a +4, right? But because we're talking about distance, we use something called absolute value. The way we signify that is I put straight bars around them. Because when I'm talking about distance between points, I just want to know how far from 0 each of them are, so I can figure out what the total is. So we said the absolute value of -9. How far was that? No, absolute value of -9. How far?
9.
That's 9. The absolute value of 4. How far from there? It's 4. So the bottom line, if I have absolute value symbols, whatever the number is becomes positive. It doesn't matter if it starts positive or negative. Absolute value is just saying how far is it from 0. Make sense? So to figure out that distance, I now add 9 to 4, and I say it is 13 units. And it takes 9 to get from B to 0, and then an additional 4 to get over to A. So that's a total of 13. I just wrote down the 2. Okay, guys. So you're going to kind of need that for your homework. Let's go to page 583.
Is that our homework?
Yes, 583 is your first page of homework. Please be quiet, because I only have 3 minutes to go through instructions. On this one, use terms axis, quadrant, and coordinates to explain the relationship between ordered pairs that differ only by sign. So you may want to do a little diagram to help you as you're talking about this. So make sure you're adding all of those terms into your explanation. For your actual exercise, plot and label the location of points P through Z on a coordinate plane. Draw a line segment from point to point, beginning and ending at point P. Describe the resulting figure. But what is it saying? It says, I'll give you the first 2. P is at 0, 5. So 0, 1, 2, 3, 4, 5. There's P. Q is at 1, 3. So 1, 1, 2, 3. There's Q. And then I'm going to draw a line from those points. I'm going to draw a line. So it's basically a dot to dot. Remember, doing it alphabetically. So you're going to P, Q, R, S all the way back. And then your last line is going to go from to P to close the figure. And then you're going to describe it. There's enough room to describe it. You should recognize it when it gets done. You can listen to the video again if you need to after. Consider our point AB in quadrant 1 and CD in quadrant 3. Plot and label each additional ordered pair. Explain how you knew where to plot each point. So this one, all they've done is they changed the A from positive to negative. So how do I know where to go? It's that same distance to the other way. So make sure you label it. So here I'm going to put negative A, 2, 4, 5, 2, 4, 5. My B didn't change. So there is point A. You're going to do that for all of these points, and then you explain how you got there. Nope, wrong one.
Not the A.
That's just point A. Point A.
That's the question. Part.
Okay, here's why we did that. Value add. This shows a map called neighborhood, a square, 1 city block. His house is at point A, which is origin. So they've given you all these points. All you need to do, write an absolute value expression using XY coordinates. Calculate the distance. You can go ahead. Let's go.